Hi, what we're looking at with 1.10 is solving equations. The first thing we have here is what is a solution? What a solution is, it's going to be a value for a variable that makes an equation true. So looking at what we have down here, for example, if we look at letter D here, it's saying whatever we can substitute in for this Q here that makes this equation true, that would be the solution. And then a follow-up for that is, what does it mean to solve an equation? To solve an equation means we need to find all of the solutions. So we want to find all of the solutions. Now all of the equations you see here are going to be what we call conditionals, meaning they're only going to be true for some values. Whereas when we look at the last example, we're going to be looking at an absolute value, which means there's going to be two solutions to that one. We have some steps here. The step one says clear any fractions, and then we're going to simplify both sides completely, move your variable terms, move your constant terms, multiply, divide, and then always check your answers. So with the first one here, I'm going to start by always rewriting it. 11 minus t divided by 5 equals 4. Well, just like step one says, we need to clear fractions. So we need to think about, what could we multiply this fraction by that's going to cancel with the denominator? Right, that's going to be a 5. Because if we multiply this whole thing by a 5, or you could think of it as a 5 over 1, those 5s will cancel. But if you multiply that side by a 5, you have to also multiply this side by a 5, because we have to keep things equal with each other. We know those 5s will cancel. That is the point of clearing the fractions. Then all we're left with is we have bring it down your equal sign, and then on the left hand side we have this 11 minus t, and on the right hand side you have a 20. Now at this point we can do one of two things. We can either move this 20 and get rid of that, or we can address this negative t. It doesn't matter. What I'm going to do first is get rid of this 20, because we want to move the constant terms to one side here. So we start with the equal sign. Oops, let's not do that. Start with the equal sign. And now we say, okay, this is a positive 11. Right, so you have to subtract 11. So if you subtract 11 from both sides, 11 minus 11 is 0. 20 minus 11 is 9. And then we have to bring down not just the t, but right, don't forget that negative in front of it, so it would be negative t. You can also think of that as a negative 1t. Now, whenever you have something in front of your variable, you have to divide by whatever that is. So since we have a negative 1, we have to divide both sides by a negative 1. Well, negative 1 divided by negative 1 is just a positive 1t, and then 9 divided by negative 1 is just a negative 9. And that would be our final answer here. And then again, you'd always want to make sure you check your answer. So I'm just going to squeeze that in over here. So to check this, you would have 11 minus a negative 9 divided by 5, and we want to know, is that equal to 4? Well, this would be plus, so 20 divided by 5 is going to be 4, so 4 equals 4. That means we did the problem correctly. All right, let's look at the next one. Let's actually go to letter C right next to it. So we have 5d minus 2 equals 13. Well, looking back at our steps, there's no fractions to clear. Simplify both sides, remove parentheses, combine like terms. Well, there's nothing to simplify over here since we can't combine them. Move variable terms to one side. Well, we only have one variable, so there's nothing to move to that side. Move your constant terms to the other, which means we need to move this negative 2 over here. So how do we undo a negative 2? Right, you have to add 2. Well, negative 2 plus 2 cancels. 13 plus 2, right, is going to be 15. And then we're just left with this 5d on the left-hand side. And then just like we did in the previous problem, if you have a negative 1t, on that one we had to divide by a negative 1. Here we have a 5d, so we have to divide both sides by 5. So start with your equal sign. 5d divided by 5 is just going to be d. 15 divided by 5 is 3. And then just like we said before, you always want to check your answer. So to check this, we want to take 5 times 3, subtract a 2, and ask ourselves, is that 13? Well, this would be 15 minus 2, which is 13, so we know we did it correctly. Now what I want you to do is pause the video and try out letters B and letter D and then check your answers with mine. Okay, looking at letter B first. First thing I did is rewrote the problem. X over negative 4 equals 2. Since we need to clear the fraction here, we need to multiply both sides by our denominator, which is negative 4. On the left, the negative 4's cancel. You're left with x equals negative 8. And here I substituted negative 8 back in to check my answer. In letter D here, well, there isn't any fractions to clear, but it says simplify both sides, remove parentheses. Since we cannot add a 3q and 4, we have to distribute. So 2 times 3q is 6q, 2 times 4 is 8, and then we have the 5q. Now, I always move the smaller variable first. Remember, that's step 3, move variable terms. Here we have variables on both sides. I always move the smaller one. So I subtract 5q from both sides, so I'm left with 0 and q, because 6q minus 5q. And then I have to move the 8 to the other side, so I subtract 8 to get q equals negative 8. The other way you may have worked through it is if you move the 6q to this side, to the right, so you're subtracting a 6q. 5q minus 6q is negative q, and then you're left with a positive 8, divide by the negative 1, you still get the negative 8. And then you can see I did check it. So I substitute negative 8 for both of my q's here. On the right-hand side, we're just getting negative 40. On the left-hand side, you have to multiply 3 times negative 8 to get negative 24 plus 4, which is negative 20 times 2, which is negative 40. Okay, moving on to the next page. What I want you to do again is I want you to pause the video and try out both of these problems. Okay, looking at letter E, first thing we have to do is distribute this negative, so negative x minus 2 plus 5. Then we have to combine like terms here, which is the simplifying both sides. Now we have variable terms on both sides, always move the smaller. So 5x plus x is a 6x, bring down your 3. Now be very careful here, we want to divide both sides by a 6. So that would be 3 divided by 6, which simplifies to 1/2. Keep in mind, we do not want to use any decimals here, only fractions. Now to check this, I used the calculator to make it easier. I first saved 1/2 as x, and it just gives me that back. And then I type in each side into my calculator, and we see that we get the same value here. That tells you that 1/2 is the solution because it makes the equation true. In letter F, first thing we have to do is distribute the 5. Then over here we have to distribute the negative 1. And then combine like terms on both sides. And then we have to move our x's first. I always move the smaller, so we add an x, which gives us 6x. And then we have to subtract an 8, which gives us 6. 6 divided by 6 is 1. Great. Now what I want you to do is I want you to read through example 2, and what we're doing here is you're solving this equation. This picture right here is just telling us where this equation comes from. So we are solving this for x and rounding to 3 significant digits. So go ahead, pause the video again, and try solving it. Okay, lastly, we're looking at this equation here. So on the left-hand side, we need to multiply these two. So think back to section 1.4 with our exponents. Whenever you have two monomials, you multiply their number parts first, which would give us 630, and we only have one x, so we bring that down. And then on the left-hand side, we have to get rid of these parentheses first, so we distribute to do so. And we get 317.65 minus 115.5x. And then we need to combine like terms, which gives us a negative 60.2x, and bring down that 317. Keep in mind, whenever you're combining like terms on the same side of the equal sign, you're just adding them together. Do not fall into the trap of adding to them. You only do the opposite when it's going to the other side of the equal sign. And then lastly, we divide both sides by x to get this value here. 3 sig digs means we're looking at these three. Since it's a 1, it doesn't change it, and we get 0.460. The squiggly equals just means approximate. All right, and the last one we have is going to be equations with absolute value. First thing we have to do is isolate the absolute value expression, meaning we need to get this expression all by itself. We see that there's being a 2 subtracted from it, so we have to undo that. Right, and we'd add it, so 7 plus 2 would be 9. And then we bring down this 5 minus 2y. Then the next step, it says clear the absolute value. So we're splitting into 2 different equations, a positive and negative of the isolated constant. This is the isolated constant. So we need to split this into 2. So 5 minus 2y equals a positive 9, and then 5 minus 2y equals a negative 9. Now we need to work through solving each of these separately. So I'm going to pause the video, work through solving them, and I want you to make sure you check your answers into the final equation when you are finished to see if you did it correctly. Okay, you can see we have to subtract a 5 from each side, and then just lastly divide by -2 to get answers or solutions of y equals -2 and a 7. And if you plug -2 and 7 into y, it'll make the equation true. Both of them will. The last thing I want to look at here is going to be something very similar, but it looks like this. You can see instead of subtracting a 2, I'm now, the operation here would be multiplying it by 2. So if we had to solve this, we'd have to get this expression isolated first. And since it's being multiplied by a 2, you would have to divide by a 2. Oops, so this would be 5 minus 2y equals a 5, and then you would have to split it into the 2. It would then look like this. You don't have to go through and solve it, but I just wanted to show you another situation that you will see with the absolute value. That's all we have for 1.10. Please reach out if you have any questions. Have a great day. Bye.